All right, so example 4, we have 3n squared minus 24n plus 48. So as with the previous examples, I didn't focus on the GCF, but still, as I stay in the classroom, as it pertains to factoring, please make sure you identify if that question has a GCF or not. So as we look at example 4, we do have a GCF, and that is 3. We're going to factor out a 3. So as we factor out a 3, what's left over, we have n squared minus 8n plus 16. Then we're going to factor the trinomial, n squared minus 8n plus 16. And this is a perfect square trinomial. Sign of the last term is positive, so we're going to have the same signs, same negatives. Break down the first term, n and n. Break down the last term, 4 and 4. And now that we have two identical binomials, we can write it as a binomial squared. But as we write our final answer, don't forget about the GCF because that was part of the factoring process. So our solution is 3 times n minus 4 squared, or 3 times the quantity of n minus 4 squared. Number 5, we have here 9y squared x squared plus 24y x squared plus 16x squared. Is there a GCF? Okay, ask yourself that question. So if you noticed, we do have a GCF, which is x squared. We can factor out an x squared from each term. So as we factor out the x squared, what is left? We have 9y squared plus 24y plus 4. Excuse me, plus 16. I'm already factoring, but that is a 16. Let's write it under here just in case if you don't see that. Okay, so let's factor that trinomial. Sign of the last term is positive, so we're going to have the same signs, same positive. Break down the first term. What two identical factors would give us 9y squared? That is 3y, 3y. What two identical factors would give us 16? That would be 4 and 4. That would be the factors of the last term. Now that 3x plus 4, 3y, excuse me, plus 4 is written twice, we can write it as a binomial squared. And don't forget to bring down the GCF because that was part of the factoring process. There we go.